This is Greg Troutwine, Marine Technology TV, and we're very pleased to be joined today by Ian Davies, the International Hydrographic Portfolio Manager of the UKHO, to discuss the recent technology and trends in seabed mapping. Ian, to start us off, can you give us a brief career background on yourself with insights on your scope of responsibilities at the UKHO?
Greg, thanks very much for having me on board today. Pleasure meeting with you and speaking with you. I've had a long career in hydrography. It started back in 1989 when I decided to specialise as a hydrographer in the Royal Navy. I completed my probationary time on HMS Herald, and I started off doing oceanography and then ended up doing surveys and mine warfare support in the Gulf before completing my Category B in hydrography. So a bit of an unusual start to my career. I then completed a number of appointments on various Royal Naval vessels and completed my Category A in hydrographic surveying in mid-1990s. And I was privileged to take command of HMS Gleaner, at the time the Navy's smallest commissioned warship. And I spent a couple of very profitable years surveying around the United Kingdom, building my experience, really getting to know what hydrography was all about. Following this, I went into a staff role and I became responsible for programming the Royal Navy's survey vessels. So I had an input into making sure that the work that was needed to be done was done, allocating the shipping to it. I then taught the Royal Navy's Category A course in hydrographic surveying for around 2 years, and then brought HMS Enterprise out of build in 2002 into operational service as the executive officer. Having done my final deployment at sea, I then returned to the United Kingdom Hydrographic Office, where I had a role in managing youth surveys around the UK for the UK Civil Hydrography Programme, as well as managing aspects of the Royal Navy's survey programme as well. In about 2006, I decided that my time had come to an end, having done a long time in the Navy. I went into the commercial sector, working for a small specialist survey company, and that opened my eyes up to the different areas that seabed mapping is done and how differently it might be. I did that until 2011, working myself up into business development and management. I then joined an airborne survey company, and over the course of the next 2 years became the director of operations. So I got a really interesting overview into new technology, the challenges of operating and conducting seabed mapping in the different marine sectors. So I did that up until 2017, when I rejoined UKHO as in the hydrographic programs team as a program manager. So I was responsible for managing one or two of the programs that we were conducting around the world. And this has now morphed into my current role, where I have a responsibility for developing programs of activity, finding funding, and helping nations develop their hydrographic capability and capacity.
You know, I know that most everyone watching this knows the UKHO name, but to start us off again, can you just give us an overview of by the numbers look at the UKHO today?
So I think it's fair to say the UKHO remains the largest hydrographic office in the world. We employ around about 1,000 staff in Taunton in the southwest of the United Kingdom, and we also have an office in Singapore. We receive data from hundreds of partners and sources across the world, and the product portfolio that we produce includes a series of over 19,000 electronic navigational charts. We make these available to the mariner through our distribution network of 182 offices, and at the latest count, around 90% of the world's major shipping has our products on board. In receiving this data, in analysing, creating those products, what we're doing is helping nations meet their international obligations. So along with meeting UK's obligations, We've got 63 other nations whom we provide more significant support to. These are what in our primary charting portfolio. So we help them meet their international obligations. And we also support over 30 digital partners in making sure that this information is made available to the mariner as required by the Safety of Life at Sea Convention. But now it's also providing a wider awareness to countries of their marine estate. And that's now being used to help around things like sustainable management and development of the marine or blue economy. I work within a small team of 10 people within UKHO, delivering 6 separate programs in UK waters and overseas. And that's done either as UKHO or working with other arm's length bodies in UK government or other organizations on a worldwide basis.
You know, obviously you have a long career in this business. So, you know, and I know it's a broad question, but using the start of your career and today as bookends, can you just discuss the evolution of the hydrographic process, putting in perspective how it was then to how it is now?
I think it's probably safe to say that at the start of my career was very traditional. So we're talking about single beam echo sounders, horizontal sextant angles, and hand inking in of sounding collectors and fare sheets, and wire sweeping of wrecks. Most people that have had a long career in hydrography will recognize these as being the sort of the tools of our trade, the products that we came to. I think at the time we were using electronic positioning fix systems such as Trisponder and maybe Hyperfix, and that helped us provide position. It wasn't great, but it was good enough at the time. Obviously, side scan sonar was a tool that we were using to help us ensure that we were detecting all of the features that on the seabed. And I think the first change that I personally think was significant was the advent of GPS. We began to use GPS as a source of positioning, and that has continued to evolve to this day into GNSS with accuracies down to millimeters, depending on the kind of ways that we handle and process our data. So that was a key step. The other one, I think, for me, was the introduction of digital systems that were recording depths, position, time electronically. That made a huge difference. You know, it made the workflows easier. You weren't spending long hours working on hand inking in from paper records. And then as we move forward into the 1990s, the late 1990s saw multi-beams begin to become more common. We began to talk about the future and how we could integrate these sensors into seabed mapping. And of course, they've continued to evolve. We've gone through several generations since they first came into being, and we're gathering much more information. We've got water column, we've got backscatter. Each generation of sensors is gathering more data. You know, when we look at the IHO and we think about the standards, 9 pings per 2 meter bin for a nautical charting survey, we struggled to do that at the beginning. Now, we struggle to get less than 30 or 40 soundings in that 2 meter bin. And that creates a new set of problems for us in this digital era. Because data volumes have grown in size. They've gone from a floppy disk to tens of terabytes of data. And that's creating a new problem for us. But it's a good problem. If we come into the millennium, so multi-beam is in, other techniques have continued to evolve and become more commonplace in what we're doing. So the first one is satellite-derived bathymetry. It provides us a really good overview. It's obviously limited to the shallower waters, clearer waters, so certain parts of the world. But what it did do is it allowed us to look at large areas very, very quickly. The evolution of airborne LiDAR bathymetry was also fundamental. From sort of 2007-8 onwards, we've seen an explosion in the capability of those systems. And the current generation of sensors now are working down to about 15 meters, maybe a little bit deeper, to IHO Order 1A standards. And what that's enabling us to do is cover large areas really, really quickly, where traditionally small boats would be struggling to operate because of tidal restrictions or safety. So all of these things have been an evolution rather than a revolution. But what they show is that the old techniques remain valid, because at times you need to fall back on the old ways of checking something, maybe calibrating your multi-beam using a lead line, perhaps trying to check a position when you're mobilizing a vessel using a theodolite. So the old techniques have remained valid. What we're seeing now is this evolution at an ever increasing rate. You know, we have an understanding of our oceans and seas, but do we know it enough? Not really. You know, despite all the advances we've made since 1990, we've only mapped 25% of the world's oceans and seas. And these new capabilities that are coming in with sensors, perhaps the development of autonomous and remotely operated survey vessels, they're going to be the key enablers going forward. So I wouldn't like to bookend the end of my career. My career has got many years to go yet, I hope. But I believe we're entering probably one of the most exciting eras in hydrography, as the acceleration of capability and the growing need for seabed mapping information pulls us into a new era of exploration and knowledge. If you have asked me for one element, I would say it was the move from analog to digital. And the digital data collection and processing, because what that's made possible is for us to use the data in many different ways. If you collected an echo sound, a trace, that was it. You got nothing else for it. With a multi-beam now, we can take our backscatter, we can take our water column data. We can do so much more with digital data. So I think that digital revolution is really quite important in sort of that evolution that I've just spoken through.
So, Ian, I appreciate that. I appreciate that overview of technologies. Obviously, it has changed mightily. It will continue to change mightily. So now we're looking at things like artificial intelligence, machine learning, grabbing headlines, not just here, but across industries. Can you discuss how these or other emerging technologies you see will most broadly positively impact hydrographic survey in the coming years?
Greg, thanks. I think I've already mentioned the issues about data volumes. They're increasing and more often than not now we're gathering more than one data type. We're taking the opportunity when we've got a vessel or a data collection platform out doing some work to gather as much information as we can. I think the introduction of AI and machine learning is going to have a huge impact, because what it's going to help us do is better manage these huge or ever increasing volumes of data that we're beginning to collect. I think a lot of people are getting quite worried about that. I think, well, there goes the role of the hydrographer. To me, I think the role of the hydrographer is just about to evolve. What it means is we're going to be able to focus our skills on more specific areas and use the machine learning tools and AI tools to perhaps remove some of the drudge. I'm sure that you may have spent many hours, as I have, processing data, and hours and hours go by and you feel as though you're still on the same rock at the end of the shift as at the beginning of the shift. So I think there's a huge role in them, and the analysis that they can do is going to be important. And if we're going to address this global deficit of data, we've got to collect more data. We've got to collect more data overall. And without those tools, we're never going to be able to handle those volumes. I think, to me, if I had to look at a piece of technology that's going to become really important, thinking about some of the ways we're heading at this moment in time, it's actually an enabler, and that's communications. The increase in speed, the greater access to satellite communications is enabling people to begin to think about putting people ashore, collecting that data, sending it straight ashore, and it's being processed literally within minutes of a line being completed on a survey. And I think that has huge implications for the way we use vessels, the type of vessels we use, and also the crewing. We know that there is global shortage of hydrographers. So we can be a little bit more clever in how we use the experience and skills that we've got as we build the hydrographic teams of tomorrow. I'd also like to say, I think, the industry is not sitting still. New generations of sensors are going to continue to be brought to market. And as a hydrographer, that drives my passion for mapping and finding new ways of collecting that information and using that information and contributing to the global understanding is a key reason why I'm a hydrographer today.
You already addressed the role of autonomous systems in the future of the work that you do. And in our pages, print, electronic, social, we talk about autonomous systems, both surface and subsurface, relentlessly. But I love to use these conversations as a reality check, because I find myself sometimes getting caught up to talking too much about the future and not enough about the present. So when you look at your portfolio today, how much activity today is being conducted by autonomous systems and how much activity is being conducted by traditional crewed systems?
I think it's important to look at where are we now. We're seeing a greater use of remotely operated or autonomous systems in a number of sectors. And it's going to become critical to mapping our oceans and seas. And when we achieve that, actually, it's going to provide that persistent presence, allowing us to monitor changes on the seabed as well as through the water column and that interface with the atmosphere. So these tools are going to provide a useful bridge between all of the sciences that people are looking at now around climate change and climate change adaptation. For us at the moment, the majority of the work that we do is still done with manned vessels. Looking to the future, I see that it's probably going to go to a blend before we step wholly over into one form of operations. And some of that's going to be driven by where are you, the type of sensor you need, and the endurance of these particular sensors. So, a remote operation in the Southwest Pacific might be more challenging to do than a survey off Falmouth on the south coast of the United Kingdom. So I think we've got to look at how we bring these things into operation. And the reason I say we're going to have to be blended is at the moment, the technology since effectively COVID has jumped forward, not in leaps and bounds, but in giant strides. And that means that the regulatory elements behind operating these kinds of systems and sensors is not yet in place. It's not yet caught up. There's a significant amount of work being undertaken at the moment, but until we get the regulatory framework in place, it's going to be very difficult to operate these sensors fully or and make use of their full range of capabilities. We've also got to think about lesser developed nations around the world. Actually, they're many years behind us, and bringing in an autonomous vessel to underdo surveys, their regulatory frameworks may not be there. So I think what we've got to do is work with other nations, build that understanding, get a framework in place that everybody's comfortable with, and then just make the transition, accepting that there's always going to be one sensor or system that's going to be better for a job, and therefore we're always going to have some form of blended activity, I think.
All technology comes with pluses and minuses, pros and cons, light and dark, however you want to put it. When you look at autonomous systems and traditional crewed systems, what are the pros and cons of both?
I think that there's two areas really that we need to look at. One is the platform, and the other is the people. Why do I say that? Well, an autonomous system, a manned vessel, they all use the same systems. We're all comfortable that the motion sensor does what it needs to do, the multi-beam does it, the sound velocity they're all using the same sensors. So it comes down to manning. So for me at the moment, and particularly as I've just mentioned, sort of working in remote areas, manned surveys tend to offer a little bit more flexibility, and that could be down to location, vessel types. You might be able to charter a local vessel and mobilize locally, which would be much cheaper than perhaps bringing a vessel in from several thousand miles away to do an operation. So there's a certain amount of flexibility there. The other one is if you have a platform like that, it's easier to add sensors or take things off. You've got the ability to experiment. The systems that we're seeing at the moment, they come with a huge range of sensors, but to integrate something new, that's quite difficult to do. So that flexibility of the platform is something I think we need to be thinking about. Obviously, manning, we know we've got the shortage of hydrographers. We need to make sure that we've got sufficient people, and that can be a con from a man survey perspective, because we're working long hours, 24 hours a day, up to a month, maybe longer. We've got to think about fatigue of the people, and obviously an unmanned or an autonomously operated vessel, they don't get tired, and you've got the ability to change people out in your remote operations center who are either controlling or monitoring those surveys. So that's one of the things I think is important. Obviously the autonomous and remotely operated vehicle are going to provide advantages with that manning, particularly as potentially in the future we may be able to operate several sensors or several systems, I should say, using one person to monitor. And that, when we think about the UN Ocean Decade and Seabed 2030 aspirations to map between 90 and 100% of the oceans, of our oceans and seas by 2030, we're not going to do that with 50 vessels. We're going to need 500 vessels. So I think that's one of the big pros with autonomous and sort of remotely operated sensors. The challenge we've got at the moment is there are a huge range of systems available to us to use, from very small micro USVs all the way up to 20, 22, 24 meter long vessels capable of deep ocean. None of them are perfect for every task. And I think because of the endurance as well, a small vessel might be 3 or 4 hours, a larger one might be 30 days. We've got to find our way through that. And I don't necessarily think it's a con, but it's a challenge that we've got to work through and understand. How do we make the most out of the sensor and out of the system and the sensors it has on it to deliver the best collection program?
Spectacular. So again, another perfect segue to my next question, because in the last 5 to 10 years, the oceans and the blue economy has come to the forefront more so than ever before. So when you look out of your porthole, can you discuss both the drivers for hydrographic survey today, as well as put in perspective the activity levels versus say 10, 20 years ago?
My background really lends itself to nautical charting, and for many years seabed mapping really focused on collecting data to provide charts for safety of navigation in the mariner. Other agencies may have collected seabed mapping data for other reasons. It could be fisheries, for protected areas, environmental purposes, and they've used it for a particular purpose. You could argue that this has created a number of data silos, because Hydrographic has one set of data, an organization involved in fisheries has another, and there's no true picture of what we have and where and to what standard. UKHO has been a proponent of gather once, use many times for a number of years, and through the international programs that we have delivered, we always make sure that the underlying data is provided to the nation with whom we are assisting in formats which they can use. And that helps them deliver activities such as marine spatial planning, development activity, disaster management, climate change adaptation and mitigation. So we're getting that data used as widely as possible. And we also encourage them to share that data with Seabed 2030 as well, or any other data that we have. Within the UK, we recently, through the Centre for Seabed Mapping, have brought together marine stakeholders, and we are encouraging greater collaboration, greater use of a common data standard, and that sharing of data to maximise use of what is actually a really expensive data set to collect. What's driving activity now is the development and management of the marine space. There's a lot of existing and new emerging sectors within the blue economy area. That is having an impact on people that are realizing they need more information. I would say we are seeing more activity taking place, but I would argue perhaps we're not. It's because our sensors are more capable, so we're collecting more over a wider area rather than spending more money, and that is going to be a critical way forward. At the present time, only about 2% of official development assistance is spent in the ocean space, and we need to increase that to help other nations undertake their data collection programs. If we can encourage that higher level of funding, I think we will see an incredible explosion in data collection activity. But I think we've got better at doing more with new sensors rather than actually achieving more with a certain amount of funding, if you catch my drift.
So Ian, so looking at it, I guess holistically, how is seabed mapping part of the ocean health conversation?
The information on the shape and type of the seabed helps us understand why currents flow in a certain direction, why tidal ranges vary from location to location, why certain habitats are richer than others in biodiversity. We also collect a lot of ancillary data as a matter of course during our mapping operations. And this information can be used to monitor and provide additional modeling at a higher resolution around such parameters as sort of water temperature, salinity, water clarity and turbidity. And to me, they're all key indications of ocean health. What we need to do is bring all of the data together, get it shared, use the UN's data model to make sure data becomes accessible to as wider group of people as possible. And from that, we'll be able to grow the knowledge and gain a better understanding of where our ocean health is actually at.
Okay, Ian, I truly appreciate your time. I just had one more question.
Yep.
I'm sure you have been involved in a lot of projects that you could discuss at great length, and I know it's probably torturous to narrow it down to one. But can you discuss a recent survey project that you or your colleagues have been involved in, a project that you see as particularly challenging or unique?
My current role sees me managing programs of surveys as opposed to conducting surveys, albeit wherever I can, I do try and get back out on a boat and do a little bit of surveying to keep my hand in. But I think the challenges of managing a survey can be extremely complex, and dealing with just day-to-day collection. You've got issues such as contracts, budget, schedules, and when you start getting involved in projects in remote regions, that's when things get interesting, I think, and that's where hydrography becomes challenging or unique. You have a higher risk profile. The minute you're thousands of miles away from your support base, you've got to think differently. What extra equipment do I need? Is the supply chain strong enough to support me if my multi-beam falls over, or do I need to take 2 extra just in case? Managing client contractual relationships, each one of those is different. Why? Because perhaps your client is not a hydrographer. He doesn't really understand the detail. Your contractor is working to a budget and to a specification. You've got to try and bring the two together and make sure that there's an understanding and agreement between all the parties involved to make sure that you have a successful outcome. When you get into doing the surveys, you've got to think about what's the best sensor type. Do I want to just do a boat survey? Do I want to do a combined survey where I use airborne LiDAR bathymetry and a boat, because that will give us the greater coverage and the best value for money? What about tides? In certain parts of the world, we have no knowledge of tides. In fact, you might get there and there's nowhere to put a tide gauge as we would normally do it. We have to think creatively. Do we need to move to a GNSS buoy solution? So I think trying to bring all of those things together, managing those aspects and making sure that the standards and specifications required by the UKHO, the client, the funder are all met, and making the best out of what you're able to collect and using it as many times as possible. I think that's the unique and challenging aspect of managing programs of activity to me now.